we got distracted. We were talking about chapter 12 because we're going to rush through it. I don't know what words I used, so I will use them all again because let's face it, some of us weren't listening the first go round. You're going to be handed the formulas on the next test. However, you have to know what shape goes with what. The next test will be next Friday. Yes, we are going to finish chapter 12. Everything for chapter 12 will be due next Friday. So I will hand you a worksheet when I finish rambling today. That's how fast we're going to do chapter 12. You're going to like chapter 12. It's easier than 11 because it's mostly plug and chug if you know which formula goes with what. That's the issue. Okay, I need help with these bell ringers, and then I want to go over that yellow sheet you were handed. Can someone tell me what to do on the bell ringer? Okay, so if I distribute -4, I promise you I will snap. If I distribute -4, I will have -4p minus 20 equals 25. Okay, what is my next step? You could distribute the 5. There's a better step. You need to add those that are like terms. Again, PEMDAS means use your parentheses first. You're creating more work for yourself if you don't check to see if there are any like terms. Now you can distribute the 5 and have -10p equals minus 100. -10p minus 100 equals 25. So -10p equals 125. That's all wrong. So what does p equal? Okay, and then what is the answer for the second bell ringer? How did you get that? It was in standard form. What form are you putting it in? Do you know? What is this? Which is called?
Slope intercepts.
Yeah, that's why we're putting it in slope intercept, so we'll know the intercept. Okay, divide by 2 on everything. You end up with y equals -2x plus 6. So she is right. That is my intercept. However, she's created a whole lot of work for herself she didn't have to do at all. The y-intercept happens when x is 0. If x is 0, that 4x piece has gone away. It's 2y equals 12, so y equals 6 anyway. I do one step in my head. 12 divided by 2 is 6. If they asked me for the x-intercept, I would cover up the y piece. The x-intercept's is at 3. That simple. Okay, on your yellow paper. Today we were talking about cylinders and prisms. I need you to tell me literally, where is the cylinder? Okay, so if you know that's where the cylinder is, go ahead and write in cylinder. I'm not going to put very many descriptions in the descriptions box. After we do notes, if you want to add in descriptions to help you, that would be fine. For instance, maybe you want to add that a cylinder looks like a can, or something that it looks like in real life that would mean something to you. You can write down the volume formula as well if you would like. I'm going to have a very short description. Tell me something you notice about a cylinder. Okay, the 2 bases, and what are the 2 bases? So 2 circle bases. I should probably say circular, but that's just too much. 2 circle bases. Okay, today we also need to talk about prisms. Do you see any rectangular prisms or any kind of prism on this worksheet?
Yeah.
Which one?
The bottom.
The very bottom I see prisms. There is a triangular prism and a rectangular prism. We are going to see a couple other kinds of prisms today. They all have something in common. We'll discuss in a second. There's a triangular prism and a rectangular prism. Tell me something you notice about the triangular prism.
Looks like a 10.
Bases are triangle.
Okay, so I'm going to say 2 triangle bases. In fact, I'm going to color those. And tell me something else you noticed about that triangular prism. What about its sides?
They're,
And how many of them are there? I've already written it, sadly. I didn't mean to. 3 rectangular sides. Okay, and then we look at the rectangular prism. What do we notice about its bases? They look like squares. We're just going to say 2 rectangle bases. They probably are squares, but just in case. And how many sides? But if that's just too much for you, the main thing we're going to notice today is the difference between the bases. A cylinder has the circle bases, the triangular prism has triangle bases, the rectangular prism has rectangle bases. We tend to name it after the base. So if it's a pentagonal prism, it'll have a pentagon base. Okay, so if you want to add to, I'll try to remember to add to this, but this handout was meant to be useful to you because, again, no offense, but some people aren't matching the right triangle area formula to the correct shape. You can't do the 2D, the 3D is just going to blow your mind. Okay, so on our notes, we're going to learn today about 2 different kinds of area. So what we've done so far is just area of this piece of paper. Today we're going to talk about 2D and 3D stuff. So there's something called lateral area and there's something called surface area. The first thing we need to know about is that things that aren't bases, I call them sides because I don't think through my technical terms most of the time. They're actually called lateral faces. Okay, so I have the thing I put my markers in. It is a rectangular prism. It has 4 sides, 4 lateral faces, and 2 bases. Why would we want to know just the area? Because we're going to find out lateral means just the area of those sides. Why would we want to know just the area of those sides and not include those bases? I can look around the room and see why. I can see, you see Tori has a water bottle that has lateral area involved for that label. Sydney with her water bottle has lateral area involved, and me and Elena with our Tervis cups. We want to put the chevron on all the lateral sides, but not on the top and the bottom. Top and the bottom, no chevron. Clear, got a lid. So we want the lateral area, I think of labels. Lateral labels, that makes sense to me. So if we're going to put a label on something, we're putting it on the lateral sides, not on the top and on the bottom. So if you want to put label somewhere on there for your future reference, you can. One of the examples we'll work today involves like a soup can. That makes sense. We need to know the area of that label for the soup can. Okay, and then the surface area is when you take the whole shebang. So not just the sides, not just those lateral faces, but the top and the bottom as well. For instance, maybe this is a gift and Danny needs to wrap it. That's where we would want to know the whole surface area. Okay, so you're going to be handed the formulas. The first formula we're going to use today is L equals pH, so lateral equals something. The P and the H are what we need to know. What do you think the P is for? It tells you if you read. Okay, it's for perimeter, but be specific. Of a base. So specifically, the P is for perimeter of a base. We're not trying to find the perimeter of the whole thing, just the perimeter of the base shape. And then the H is height. Yes, it's height. But we need to write a term for that. Because, I mean, what is the height? How do we decide, is this right? Or if I stand it on its side, is that the height? How do we know where the height is? So we're going to be very specific. The height is the length connecting the bases. So if you can find the 2 bases, and you can find a line connecting the 2, the number on that line is going to be the height. Okay, so our first problem involves a regular hexagonal prism. My formula is L equals pH. What number should I put for my height? I should put 12. So connecting those two bases is how you find the height, and it is 12. Okay, but for the P, I need the perimeter of this hexagon. What is the perimeter of that hexagon?
5. Right now. 30.
How did you get that? 5 times 6, because it's a hexagon and each side is length 5, so 5 times 6 is 30. Okay, there's a key word in that lets you know that each side is length 5. What is the key word? What's the key word in our problem that lets you know for sure that each of these are the same length?
Regular.
Regular. If you don't see that word regular, this magic math we're doing will not work. Okay, what is 30 times 12? It is 360, so 360 centimeters squared. So I like these. They tend to be plug and chug. But people mess up, and we'll talk about in a few minutes how they might plug in the wrong number, or I don't know, they mess up things because they're not paying attention. It is life. Okay, same formula, different shape. We now have an octagonal prism. I need to know the height of my octagonal prism. The height is 9. Again, find that number connecting the two bases. So the height is 9. I need to know the perimeter of one of my bases. You did 3 times 8 and you got 24. But again, that key word of regular is why we know for sure that each side is the same length. If it doesn't have that regular word, not all sides are going to be the same length. Okay, 24 times 9 is 216, so 216 centimeters squared. So again, what we're finding is the label to put on those weird looking cans, or those weird looking, those aren't cans, those weird looking prisms. We might need a label for those. Okay, now we might want to find the entire surface area and include those bases. So we see there's a new formula, but all that changes is you take the lateral and we're going to add in those two bases. So that's still for lateral. Plus pH is lateral, so those two mean the same thing. And then we need 2B. But I need to know what B actually is. But very specifically, read through the formula. What does it say B is standing for? Yes, it's each base is area. So we need the, I need to write that word out. We want the, it's 2 times the area of a base, or I'm just going to say area of a base. The B is for the area of a base. We need the area of a base. Okay, but I still do the same thing. I first find the lateral area, and on the test, it'll be 2 different blanks. One blank for the lateral area, another for the surface area. So you end up finding the lateral area every single time. Okay, so I need the lateral area, which means I need the perimeter, and I need the height. What number should I put in for the height? Because that's the number connecting the two bases, so it is 12. I need the perimeter of my base. It is, because this is a square, we're shown that, so 6 times 4 is 24, so that is 24. So my lateral area is what number? This time I'm not done, because it wants the surface area. To find the entire surface area, you need to take your lateral area plus 2B. So that means I'm going to do 288 plus 2 times B, where B stands for the area of my base. What is the area of my base? What kind of shape is my base? So it's base times height. So it is 6 times 6. So it is 36. She is correct. So I plug in a 36. Does everyone understand how I got 36? I did the area of my base. My base was 6 times 6 because it's a square. So it's 36. From the perimeter, yes, 6, 6, 6, 6. If you add all those up, you get 24. Okay, so you did 288 plus 2 times 36. You end up getting what number? So it's 360 centimeters squared. Are there any questions about how I did this one? We took the lateral. We did 2 times the area of our base. I even found the area of my base over here. Yes, dear. So Sawyer does something wrong. He gets the wrong number here. That's fine because Sawyer shows all his work. So I'm going to see what he did and where he messed up. And I can only take off points where he messed up. After that, if he did the rest of the steps right, I can't take off points for that. But if Sawyer did what some of us continue to do and just write some magic number out of thin air, I don't know where it came from, I don't know where he messed up, I get to take all the points. Actually, I tend to give you like 1. Okay, so let's find the lateral area of this triangular prism. I need to know the perimeter, I need to know the height. One of those is easy to find, one of those is not. What is the height?
No.
The height is 10. Okay, so the first mistake we're going to make happened in this problem, and I knew it would happen. We're so used to the height being 8, we forgot that we made a note to ourselves. Height in that lateral formula stands for the number connecting the 2 bases. The number connecting those 2 triangle bases is 10. So the height in this formula is 10. It's a very common mistake. I'm glad we made it. Okay, but this problem's missing that word regular. So we don't know that that's an equilateral triangle. We don't know that that perimeter is 36. I know you want to do 12 times 3 is 36 and move on, but we don't know that. So instead, because it's going to haunt you until you finally leave me, and probably a little bit after that too, we need to solve this triangle. It's a right triangle. Does anyone know what number already should go on that hypotenuse? Okay, so if you want to think about it, it's a 6, an 8, and then this one is 10, because 3 times 2, 4 times 2, 5 times 2, it's a multiple of a 3, 4, 5. Now, could you have used the Pythagorean theorem and done 6 squared plus 8 squared equals x squared and solved and gotten 10? Of course. You can always use that Pythagorean theorem if you have gotten your triples. If we were to solve the other triangle, it would also be 10. So our perimeter ends up being...
Teachers, at this time, I need those students who are going to the superintendent and student council advisory to go to the bus. It's a back bus canopy by the cafeteria. Those students need to be dismissed to the bus canopy by the cafeteria. Thank you.
So our perimeter ends up being 10 plus 10 plus 12. So our perimeter of our triangle is 32. But again, we wanted to guess that it was going to be 36. So did I. But again, that word regular is missing. So I don't know that this is an equilateral triangle. So I actually had to solve and use those chapter 8 skills yet again. So my lateral area is 32 times 10, which is 320. Is there anyone who's confused about how I got the lateral area of that triangular prism? Okay, well, I need to find the whole surface area. And surface area is your lateral number plus 2 times the area of your base. So I know it's going to be 320 plus 2 times some number. I have to find the area of my base. What shape is my base? What's the formula for the area of a triangle? Okay, so I like 1/2 base times height. My base is what number of that giant black triangle? That giant black triangle. The base is 12. The height is the 8, finally. So you do 1/2 of 96. You do end up getting 48. She's not crazy. But again, if Danny makes a tiny error, if she's showing all her work the way I'm showing all my work, of this is where I got this, and Miss Compton can follow it, then I can't count off that much. Okay, so your final number for the surface area is, say, 416? And they didn't tell me a unit, so I'm going to just say unit squared. Okay, is there anyone who is confused about that example? Then flip to the back, because we've only really done prisms. We still got to do lateral and surface with cylinders. Okay, so you say, Miss Compton, a cylinder, a prism, they all look very similar. That's true, but those circles means pi starts getting involved, so our formula has changed. For the lateral, we're going to do 2 pi RH. But the h is still that number connecting those two bases. So for instance, on our first example, that h is still going to be 18. And as a friendly reminder, based off some of the tests that I have graded, I know we've not covered the circle chapter, but you learned this a long time ago. The entire thing is called a diameter. If there's a line going across the entire circle, it's called a diameter. Half of that is called the radius. So the 14 is the radius. Right now the diameter would be 28. So make sure you're not getting that circle parts messed up, because that's just going to throw everything off for you. So our lateral is 2 pi RH. So 2 pi, my radius is 14, my height is 18. I type that in the calculator, I get some number, which I need. I need it.
It is 2216.
I don't believe you. Okay, and then read the directions and tell me what you got again. Okay, so Danya is reading the directions, because I've started counting off, because you can read with the best of them. 10th means 1 decimal place, so it's 1583.4. Okay, help me find the lateral area for this cylinder. And it can be a really big number. Think of like the tank farm exits. Those are really big things. They would have a really big surface area. What's the radius? What's the height on my other example? And the height is, it's really hard to read, it's a 20. The copy machine is finally fixed, so that will no longer be an issue. Okay, you type that in your calculator and you get, okay, well you get 1057.96, but again, when we're reading directions today, it says to the nearest tenth, so Toby is correct, we would round that to 1,508 feet squared. Okay, and then you can read. Have we done everything we were supposed to do? No, why have we not? We found the lateral, yes, but we've still got to find that surface area. The surface area for a cylinder is just like with a prism. You take the lateral, you add 2 times the area of your base, but our base in this case is a circle. So it's going to be L plus 2B. Well, we already found L, that's 1583.4. Now we just need to find the area of our base. What is the formula to find the area of our base? What is the radius of our circle again? So I need to know 14 squared times pi. I need that number. Okay, you did 75. I'll do that. I like that better. I'm not going to round to the end. It's better math that way. So 615.75. You type the whole shebang in your calculator finally to get that whole surface area, and you get point what? That's what I got as well. If you had rounded, which Isaac did, he rounded intermediately, which is not a good habit, but I can live with it. If that's the worst habit he has this school year, I'm okay with that. So if he got 2815, I'm going to give him all his points. If he got 28814.8, I'm going to give him all his points. Let's face it, if he's got the 281 and he's real close, I'm going to give him all his points. Okay, so let's do the same thing on the other example. We still need to find the surface area of this shape. So it's L plus 2B. My lateral is 1508. I need to know the area of my base. Again, my base is a circle, so it's going to end up being A equals pi r squared. So A equals pi 12 squared because my radius is 12. I need to know that number. Do 3/8. And then tell me what giant number I'm supposed to get. Mm-hmm. Okay, so we found the lateral area, we found the surface area, and finally we get to why this should be useful in life. Because on the ACT, they're not going to say, hey, Sydney, it's a lateral area problem. They're not going to do that. They're going to have some sort of word problem like this. A soup can is covered with a label shown, so it looks like a Campbell soup can to me. What is the radius of the soup can? Okay, when we put this label on the can, what is the can? What kind of shape is it? A cylinder. So we need the lateral formula for a cylinder. What's the lateral formula for a cylinder? Perfect. We need to find R. Somehow we need to know L, and we need to know that H. When we take our soup can and we wrap this label around it, we decided the number that connects the two bases is the height. What number would be connecting the two bases when we wrap it around it? The 8 or the 15.7? The 8. So I know my height is 8. But then I'm stuck on the L. I'm stuck. And I need to think this through. Unless Katie's wanting to get fired, a good soup can, the label's going to fit it just so. It doesn't go over. It's not too small. It fits it just so. Can we find the area of that soup can label? Because the label of that, if I had, I wish I had peeled off a label. So, yeah. So, the lateral area is it wrapped all around. And then the label itself is, we know its area, we can solve it. And it's supposed to fit just so. Because right now, if Katie leaves this gap, she's fired. So, it needs to fit just so. Not overlap much, to be just perfect. So the area of this and the lateral area should match. So let's find the area of that label. Yes, because A equals B times H, so A equals, the base is 15.7, the height is 8, so 15.7 times 8, which is, say it again. $125.6. So my lateral area is 125.6. So I have 125.6 equals 16 pi r. Because I did 2 times 8 and got 16. And now everybody who's not r has got to go. So I'm going to divide both sides by 16 pi. When you type that in the calculator, you should be able to give me the radius of that soup can. Either that or Katie's fired because her label's too big or her label's too small. It is, I got 24.7. It was like 6 something or other, and it rounded up to 24.7. Okay, and then the second one is not bad, but we're running low on time. If you want to try it later and come see me, I would talk to you about the answer. It involves a little bit of factoring. That's why we're going to skip it. Again, they're not going to say, hey, RJ, this is a lateral surface area problem. They're going to ask a real life thing, and you're going to have to apply geometry to it.